In this question, we are told there is a student who pulls a horizontal block with a spring scale, like so. Does it a couple different ways and records the force as he travels a certain distance. We want to know which one will be moving fastest at the end of 1 meter. So we want V to be the greatest. Let's first do an analysis of our graph. We have our RGA. We can read force and distance. The slope is delta F over delta D, which has units of newtons meter. It's like the spring constant. And the area is force times distance, which is the work. And the work is equal to the change in kinetic energy, since this is a horizontal system. Now the ideas here, we have velocity we're looking for. Momentum is mass times velocity, and kinetic energy is 1/2 mv squared. So we could see then, oops. So we can see then that the kinetic energy is really very closely related to this. So what we're looking for is the area to be the greatest. Area is the greatest. So we see this area here. We see this area here. So we can see the area is greater in B than A, so we could take choice A out of the mix. And now we compare B with C. If we look at this little triangle and this missing triangle, we see that if we rotate that around the axis, they are equal to each other, which means it has the same as choice A, has the same area as A. So that is out for the same reason as A. Then we're comparing B and D. So, of course, we have our similar yellow. And, of course, then we see that there's this triangle versus the rectangle. And clearly we can see that the blue is less in D than it is in B. So that means our best choice is B. We'll have the greatest area, which is the work. The work will bring about the greatest kinetic energy. The greatest kinetic energy for the same object would be the greatest speed.